There's a lot of unknowns out there. There are vulnerabilities that have to exist and do exist, but the vendors haven't reported them.
How would you explain firmware to the average person, or how they should think about it? Welcome to CGI Voices, where CGI's experts share insights on the latest in federal government management, policy, and technology. I'm your host, Pete Tseronis. We're here today with Chris Lavergne, Vice President, Director of Consulting Services, and a CGI expert, and David, also known as Dave, Crawford, Director and Lead Cyber Architect here at CGI. And we're going to dive into a topic that I know you two are very intimately involved with and passionate about, cybersecurity, but we're going to delve down into some really specific stuff, i.e. firmware, compliance, and optimism around where this cybersecurity, physical security landscape is headed. But without further ado, a little bit about Chris. 20 years at CGI, providing IT integration and information security services for agencies across the U.S. government, both civilian and defense. He's hailing from the Citadel, originally from Poughkeepsie. Lots of colleagues and friends of mine from that neck of the woods, and he has a BS in biology. So aside from being a cybersecurity expert, I like that background of yours, Chris, and we'll dive in and hopefully talk a bit about how that informed your journey. Dave Crawford, Lead Cyber Architect in the National Security and Justice Business Unit here at CGI Federal, an expert. If you look up Dave, you'll see a lot of acronyms after his name: CISSP, PMP, CSM, SSM. Maybe we'll break some of those down, those acronyms, but that tells me you're a dude who knows a lot about this space. You are a U.S. Army veteran. Thank you for your service, big time. I'm excited about this conversation because Cybersecurity Awareness Month every October is here and now. And I think when we dive into this discussion today, we're going to set folks up with an understanding of cybersecurity never stops, at least in terms of mitigating risk, but also it's that time of year where I think we can get folks excited and educated, informed, and enlightened, as I like to say, about things in this vast, pervasive space. So with that, Chris, why don't you tell us a little bit about your journey to CGI? The same question will come to you, Dave, and let's get our audience aware of what brought you to this place, why you're so passionate about it, and what's informed you along the way, without giving away too much, because we have a lot to talk about.
Sure. Well, I got involved with IT, both as an instructor and as an implementer. Through that, became involved with Stanley Associates. I worked for various agencies as far as implementation infrastructure, identity and access management, all sorts of things. It went through a DoD contract at JSF, and from there, we were acquired by CGI, which is where I've spent the rest of my career supporting EPA with their NSOC work, and they're standing up a new CCERT capability, and then eventually came back to Virginia to support a DHS program called CDM.
Wonderful. And what I took away from just that is you've seen so much of the evolution of technology, its modernization, its transformation, and with that is there's increasing, or I like to say exponential risk, and we're going to get into that. You agree?
Amen.
Awesome. Dave, your journey.
I came to CGI kind of the traditional way that people come from one contract to another. I was working at the EPA, and CGI won a contract, so I did the badge flip thing, but I came to that through being a developer. Started my career as a cost analyst doing space and missile systems cost estimating. Things have changed quite a bit. Obviously, when I came in, we were doing single computers, maybe small networks. My first actual role in that was using dial-up to a timeshare system. So came to cybersecurity kind of accidentally through doing, as a developer, came to do security code reviews, supporting the Postal Service. That led to the role at EPA eventually because I was doing systems assurance work. I'm a generalist with specialized skills, and Chris and I actually started working together even before we were, when I was still not with CGI, because of the projects we were on. And so, now here we are sitting side by side, and essentially are, literally offices next to each other supporting the exact same programs.
With that, let's jump into a topic that maybe kicks off the rest of the discussion, and that is, look, I'm a big proponent of understanding and conveying critical infrastructure and the cyber-physical security and systems that could allow for modernization of that infrastructure, our bridges, our water, our air, the energy sector. But then there's that opportunity and art of the possible with, as I mentioned earlier, this risk that we present when we connect more devices. So let me come back to you, Chris. The cybersecurity landscape, the Internet of Things, the interconnectedness, paint the picture of how this world has changed, and every day there's a threat, but an opportunity to mitigate that threat.
Sure. I mean, just look around. I mean, everything you see these days, from your watch that you wear right there, everything else is interconnected, right? So we have, look at your home Wi-Fi network, right? How many things, when you first set up a Wi-Fi network, back 10 years ago, maybe you had 2 things hooked up to it, yours and your spouse's computer or something. But, nowadays, if you look at it, you're going to have 40 devices, 50 devices in your home on it, right? Because your TV, refrigerator, everything's in there. Well, think about actual compute environments, right? So there's so many devices that are either real or virtual or interconnected, or an IoT device that's phone and home, that are all out there. It's just much more complex. It's the same, but more, so much more, that it's almost impossible for humans to effectively manage it in a manual fashion.
When COVID hit, we all were working from home. I didn't realize how many devices I had in my house until I had to upgrade my Wi-Fi, and they said, man, you got 60 some devices in here. I'm probably telling the world that, but hey, I've had lockdown. I didn't realize how much I had to think about those other devices that could be backdoors into what I was doing, which was my work from home. So you mentioned Internet of Things on top of my reference to the acronym. That's IoT, folks, the industrial Internet of Things. If people wanted to Google that phrase, it is that equipment that is really supporting a lot of the critical infrastructure, industrial control systems. So we also want to make sure everybody knows we're not intentionally throwing out acronyms, but look them up and understand where things are at risk. Dave, your thoughts on this cybersecurity landscape?
Everything old is new again. And the landscape is dramatically different, but the things that we're talking about, firmware, have always existed. Firmware is the integration between hardware and software. So from the very beginning of computing, you've had some elements. At some point, that firmware may have actually been literally a human. I mean, you were wiring things together. But going back to the basics, you talk about BIOS, the basic input-output system. That's, the drivers, not software drivers, but that's a driving functionality that actually causes things, permits them to work, and you have to be able to go through that. So the difference is that we've changed size, we've changed scope, we've changed volume, and it's everywhere. But you used to think about things only in terms of the physical. You had a computer under your desk, or you had the mainframe down the hall in the data center. Well, we still have data centers. I mean, a lot of people have outsourced their pieces to the cloud, right? Well, okay, so you never see it, but there's still compute resources there. And you ever see a picture of a data center that's, cloud data center, there's racks as far as the eye can see. I mean, it looks like the warehouse at the end of Indiana Jones. You just can't see the end of it. But if you have your compute resources in the cloud, you still have to be concerned about firmware, because that firmware is in those racks and chassis. Now, we can get down into the shared responsibility model and what your contractual relationships are and what the FAR clauses say and all that other kind of stuff. But at the end of the day, somebody's responsible for dealing with the physical and cybersecurity of your resources, no matter where they are. And if you're at your house, it's you. If you're here in the office, it's maybe your ISIT department. If you're a federal agency, well, then, that's somebody's responsible, but, it could be a contractor down at the basis who's running, who's actually running the equipment.
Well, 100%. And you, thank you for laying that out, because we're going to dive into this term firmware, which I love the everything old is new again. I mean, fads or not, it's like we have to understand the things that are there in every device if you really want to understand how to protect when you buy that plug and play quote unquote device from Best Buy or somewhere that says, hey, you want a camera that might watch your kids or something. There's risk to that element, which is probably run by application software, but the firmware still critical to understand. So it is software. It's stuff that most people don't probably ever see if you're an average person like myself, even though I've opened up a few computers in my life. But it's specific, and it's the root, if you will. That's the fundamental, if I can say, element of software, type of software that we have to be thinking about, because it does communicate with all these other variations. How would you explain firmware to the average person, or how they should think about it? Because it's going to dictate a lot of what we get into today.
So firmware itself is just software, right? But it's software that's embedded on a compute chip. So it's there, and it's specialized. So the BIOS chip, or the basic input-output system that Dave was talking about earlier, that's sort of one of the big ones. And that is for an OS to talk to, right? So you install Windows, you install Linux, whatever. It's going to interact with that BIOS chip, because the BIOS chip is going to start up the computer. It's going to run the computer. It's going to know how to reach out to all the other firmware chips that are on there, so that you can drive a wireless device, or a hard drive device, whatever, storage devices. All of these things have many embedded chips. The term firmware implies that the software can't be changed, right, once it's on there, and that's true for some firmware. But there are firmware that can be updated, right? So when you do find things, some firmware can be updated. There's all sorts of acronyms we can use, of ROM or read-only memory, and then there's write once, read many, and there's lots of different variations. But just think of it as ones that can't be changed, right? So if you needed to do an update, the chip would have to actually be changed, or buy some new hardware. Or if it can be updated, often you can just go ahead and flash that chip, so that it updates a new set of instructions.
Do you find that people think about that, though, when there's this constant? No. I knew you'd say no, but the context was the government, right? One of the customers that a large customer, and it's commercial too. We're always upgrading equipment, end of life, no longer supported, and we buy the new stuff. And I'm hearing you say, look, you got to think about what's talking to that new equipment, correct? Is that where you were going, Chris?
Oh, yeah. So some of the depending on what these chips do, right? If they have a communication function, they can be phoning home to where they were first built to look for updates. They can be, doing any number of things, right? Reaching out, pinging. So for instance, in a thermostat example, right? When you say you have your thermostat, it's hooked up to your phone, and you like to change the temperature by your phone.
Guilty as charged.
You're really not doing it directly, right? Your thermostat's communicating back with the manufacturer. The manufacturer runs the web services that come back and control your thermostat. You're communicating with the manufacturer. The manufacturer's services then are controlling that thermostat. So there's a whole path that goes on there, whereas you're thinking, oh, I'm just changing my thermostat. Yeah. Well, you're not. A
lot of stuff
working through the whole thing. Same thing with locks and all sorts of things out there.
A lot of stuff's happening in the background. I could tell Dave's itching to get in here. Dave, let's take firmware from your perspective. Give folks an idea of how to think about it, but also, use some examples of why we need it, but also why we need to care about it.
Well, and there's last month, there was a major ransomware attack that hit MGM and several of the casinos, in Las Vegas that, basically disabled everything. Took their entire system down. So Chris mentioned locks. Well, you go in a hotel these days, you don't get a key, right? You get a little, prox card that you go up. Well, if you disable the locks, some of the elevators you can't move without going to the, tagging your badge or your key, and then it knows what floor you're going to. You can only go to the floor you reside on and to the casino or whatever. That was all shut down because of attacks. Now, not necessarily through firmware, but the reality of it is that firmware, like software, like other things, has vulnerabilities, and there are paths by which nefarious actors can engage. So you're going to the, when I talked earlier about the data center, you're outsourcing certain things. When you're looking at, physical controls and those kinds of things, you talk about man traps and the guns, gates, and guards and all the rest of that kind of stuff. Well, okay, that's a high degree of protective posture, but it doesn't necessarily mean that you're going to get everything. But get out of the data center and start thinking about where somebody has physical access. I mean, physical access is king. If you have your hands on the device, kind of all bets are off. But from a firmware perspective and things that people need to consider, thinking about it in the federal space, right? Everything that you have in your environment that has compute resources is going to have firmware. It's going to have driver updates. It's going to have, your laptops get BIOS updates, et cetera. You got to deal with it. The difference between a lot of firmware pieces compared to, say, getting an operating system update for Windows or your iOS updates for your phone or Android or wherever you're getting is that a lot of times the firmware is a on-demand situation. You have to look and see what you have. Has the vendor provided a new version of it? Then you have to proactively go get it. Then you have to come out and you have to apply it. Well, applying some of those updates requires outages. So there's a whole series of the things that are just operations. We'll dive down the compliance rabbit trail here eventually, but the reality of it is at the end of the day, you got to functionally deal with all of these things.
So let me think about this, and this is coming off the top of my head. I think of my iOS, right? We get update alerts all the time for phones, and I'll stay brand agnostic. And I know people like, I don't want to do the update, because you know what? It's going to cause my other apps not to work or this, that, and the other. And that to me is, I'm of the ilk, update it. They're telling me that they made some changes, and I'm going to trust that everything will work. And that's one way of looking at it. Let's look at from a customer though, right? That's from a consumer, people can choose or not to. When you're supporting a federal agency, again, I want to go to an example. Let's go to the compliance, and maybe you'll stick with Dave for a minute on this one. We see binding operational directives. We have cybersecurity strategies. We have NIST standards that are being developed because of or in response to a ransomware attack. Colonial Pipeline happened, right? And that kick-started Executive Order 14028, which introduced operational technology, asset discovery, what assets talk to what physical assets talk to those internet assets. So can you folks maybe talk about when you're called for or when you're helping out an agency, think about this swath of things. Is the answer, well, we'll just outsource it and they'll handle it for us? What's your take on the government embracing this, but also trusting they work with the right partner?
Yeah, so one of the things I think we need to kind of set this foundation for is the kind of the landscape. So you mentioned the CVEs, or common vulnerabilities and exposures, enumerations. Those have been around for quite a while. CISA has started as a result of a number of different things, tracking the known exploited vulnerabilities since about 2021. And just recently, September-ish sometime, that number of vulnerabilities out of the broad number of vulnerabilities crossed 1,000. And they're adding 2, 3, 4 a day at this point. To be on that catalog, and that there's a binding operational directive about this, which is 2201, which is
fiscal year 22, the first one that fiscal year.
Dealing with known and exploited vulnerabilities. To be a known exploited vulnerability, it has to have 3 things.
Okay.
1, it has to have a vulnerability, CVE identified by the vendor. 2, there has to be a remediation provided by the vendor.
Okay.
And 3, there has to be a actual in the wild exploit for it. Sounds like good news.
Meaning, did it has to have been, it has to have happened?
It has to have happened.
Okay, keep going.
Sounds like good news. And it is in a lot of cases, except there's a lot of noise. But the part that comes back into firmware that is the not so good news is that there are vulnerabilities that have to exist. You know, it's like a black swan, right? We didn't know whether there was a black swan until we saw one. But there are vulnerabilities that have to exist out there and do exist, but the vendors haven't reported them. So they don't have a CVE number. Because they haven't been reported, there's necessarily no remediation for it.
Can I ask a dumb
But
question?
there might be a known exploit for it.
Okay, why wouldn't somebody report that?
Well, partly because they might not know.
Okay.
The other part of it is that, when we talk about the integrated supply chain, the vulnerability might exist in a piece of your firmware that you didn't know you had or you didn't know that you included. So, I'll kind of pivot, I guess, and let Chris kind of fill in or do however. But as part of the executive order you talked about, National Institute of Standards and Technology has been directed to come up with a software bill of materials strategy, which is enumerating everything that belongs wherever. You've got multiple attestations by various providers, first party, second party. But one of the challenges you have is the embedded systems, where you have a library that is in use down in the weeds somewhere that maybe is the original provider you didn't know you had. And so the part of this is when you get into the conversation about discovery and all the rest of that is discovery is more than just simply identifying the device on the network, wherever it is. You have to know the lineage and life cycle and all the rest of that. And lastly, right at the end of September, CISA added to this list a hardware bill of materials framework, which is to help people understand, purchasers, what did I buy and what does that hardware consist of, to the extent of what chipset is on it, so that you can chase down the that list of things that Chris talked about this chip talks to that chip, which talks to the other chip. Now you've got relation. It's not only the software world, but it's the hardware and that interconnect on some physical board someplace.
Well, we touched on a couple things here. One is never to think of firmware as just a single chip on a single device. It's multiple chips, right? They're all communicating with one another. That's one thing. Another is a lot of times they especially with firmware, right? If it is a actual firmware, that can't be rewritten, and that vulnerability is live, there are compensating things that can happen. But the only way to really fix it is to replace the chip, right? So typically, you're not going to want to do that. The bright side of this is that a lot of the chips, right, in and of themselves, are only built so that they can create that bridge between your OS and the function of that chip. So a lot of times through a software patch at the OS where they update a driver, right? So a driver is just a piece of software that an OS uses so that it can actually, talk to a chip and tell it what to do, and then the chip can go do
like
a
traffic cop.
Exactly, and a direction giver, yeah. And so you can find, so there was a few months ago, there was all these vulnerabilities around certain generations of Intel chips. Those were basically mitigated with software patches. They were able to do that rather than, because they couldn't actually change the actual CPUs out. They couldn't be updated in and of themselves. So they were patched by way of OS patches.
So let me jump in for a minute. Like this patching and constant understanding what's the lineage of that hardware that I bought, the software bill of materials, hardware bill of materials. If there is, and it comes to mind, let's let everybody know, if we can, where they can find some of this. I assume at CISA.gov there's some downloadable documents really quick.
The catalog of KEVs is available publicly. The CVE list is available publicly. There is a ancillary, but it's a little generationally outdated. There is the Common Platform Enumeration, CPE, also published by NIST, which attempts to describe in some cases, hardware elements, there's like one out there for Xboxes as an example, as well as software elements that vulnerabilities in the CVE catalog may apply to. So the firmware scenario, as an example, is there's roughly 22, 23% of the KEVs as of March of 2023 on the KEV list related in some way to firmware. So you can discover these things. It's just that the part of it is you gotta, the bad analogies of haystacks and needles, but you've got to figure out what haystack you got to work with first.
So go ahead,
I was
Chris.
just to say that, and that so it's available. Not only is it available, right? These KEV lists, and they're curated, made available by CISA. The vendors are adopting them as well, right? So your more popular, vulnerability management vendors, without saying any names, we'll go ahead and allow you to check a box. They'll use the KEVs. They'll bring that list in to make sure that they're paying special attention to those, have all the right plugins to find those kinds of things, so that folks know whether or not they're being exposed to any KEVs, any known exploited.
Yeah. Well, now I have a question as being a former Fed, or even today. And again, share what you can and you're comfortable sharing. But now back to your CGI. I mean,
Sure.
People dial your number to say, come help us, I would assume, with all these new pieces of documentation. Maybe there was an IG report. Maybe there was an audit. Maybe there was something that said, who can come in and help us, fix this and get us on the right path? Do you both have some examples of, I don't want to say best practices and what should work? And let's get a customer example of how to think about this versus thinking there's a pixie dust that can be woven. I'll call CGI and everything will be fine in a week.
I think part of it is going back to kind of some of the basics of the cybersecurity framework and also risk management framework is, what is your risk appetite?
And these are from the NIST.
From NIST and
NIST
the
body of
programs,
knowledge,
and
right.
You've got, but part of it is that the vulnerabilities, the KEVs and others, they in addition to just existing, they have rankings. They have a base score related to the criticality of potential risk, and you look at some of the binding operational directives out there, there is a lot of, you need to do these things, and you've got to do them in this time period. But this is all cyclical, right? So about the time you get a plan together to deal with last week's fire, all of a sudden there's another fire you're dealing with. And so part of this has to do with coming up with an understanding about, what do I need to patch and when do I need to patch it? If and you got to do an assessment. Is like, if I have a very critical vulnerability, but it has a relatively low risk of exploit because of the physical controls or compensating controls that Chris was talking about, I don't want to ignore those, but I'm going to put them into a pocket of things that I will get to when I can, because maybe those are on a patch-sensitive system of some kind. Maybe you are in critical infrastructure, and that is in an environment that has.
You can't just turn the grid off for a minute and fix
maybe
that.
Maybe you only have a couple of hours every 6 months as a maintenance window. Well, I'll put those in. Meanwhile, over here, you've got something that has it's moderate risk, but has a near certainty of exploit if you have it exposed. Well, maybe the answer is we used to think about fix the worst first. Well, worst is relative.
Chris, before you comment on that, I'm just going to go back to these documents that exist I don't take them because I've read them. They're not prescriptive. They're there to say, look, what is the risk profile you at agency X, Y, or Z? We're talking a lot about some of the critical infrastructure entities, the utilities, the commercial vendors who own and operate a lot. I mean, the hope is they're doing some assessment. But when it comes to federal agencies, right? Agencies that are like, well, we want to subscribe to this because we have systems at the Department of Labor, at the Department of Agriculture, bring in a CGI. I mean, there's plenty of technology and systems and networks and outsourced vendors that could leverage these frameworks in addition to the ones that have to be defined tomorrow. Is that hard for you folks too? That's the next kind of, how do you, again, the roadmap, calling you up, you're clearly smart individuals and know how to address it. But the government, wants to say, I don't want to be on that list, and seeing my secretary testify on the Hill, it's not an overnight fix, but it seems like you folks know that there is a process, but it's also educating a lot of those people as well, even if you're the folks that come in to fix a problem. So, Chris, what are your comments?
Sure. I was going to say, for practically, right, when you want to go help somebody with these kinds of things, the first thing you need to do is figure out what's out there, right? So certain things can help. I mean, there's FISMA reports, there's all these different kinds of things which kind of give you ideas, but you want to have observable information, right? So to do that, you use network tools, discovery tools to go ahead and find everything that is findable, right? Because if it's on your enterprise network, it's got an IP address, IPv4, IPv6, whatever, dual stacked, I don't know. But we would go in and try to find all these devices. And you try to go ahead and categorize those devices. So you're working on that. And then from the categorization of those devices, you know what kind of devices they are. So you have an idea of how many are sort of endpoints, Linux, Windows, what have you kinds of devices, what kinds of things are sort of network devices, right? So router, switch, wireless access points, what have you. And then there's a whole IoT category, right? And then there's mobile.
Now we're getting into this asset discovery, or what I like to say, the exploration component, the enumeration. So I'm going to ask you both to that this is called out in Binding Operational Directive 2301, hint audience, fiscal year 23, last year, first one that came out. And these are DHS types of documents. The federal government likes to have NIST this and 800 series that. Binding Operational Directives are important in the world of Homeland Security, where they introduce this, where are your devices?
It goes back to the basics, and I know a lot of times people say, I've heard this all before, right? It's basic blocking and tackling. It's identify. That's step one in the cyber security framework. Identify, protect, detect, respond, and recover, right? Well, we got to identify. So Chris said, monitoring, we talked about, network packets don't lie. Right, so if you're monitoring what's going on the network, and you have the ability to say, okay, there's ways to fingerprint devices, so you can answer the question, what is this? I mentioned the vending machines. I went to a customer site as part of our original engagement with CDM, and we were kind of talking about pain points. And we were talking about this identify scenario. And then we go through and he says, I've got a vending machine problem. And my immediate response was your response, okay, I got the Pepsi machine or the candy machine down the hallway. And Chris alluded to is, no, he's got an industrial vending machine issue. Initially, he didn't know he had this problem. Industrial tool shop, specialized drill bits. You go up, you swipe your badge, you get a particular kind of drill bit that can be used for whatever operations you have, and then periodically that vending machine has to call home to its supplier to say bin D3 with whatever drill bit is in there is low, come refresh. Well, that's all great, but if the tool shop manager just plugs that in because he's got a new contract with a supplier that he didn't tell ISIT or security about, and all of a sudden you've got something on your network you don't know about. So there's a lot of unknowns out there. And with every kind of smart TV and set-top box and who knows what it is, there are probably somewhere in your facility someplace, somebody's got an Alexa device, or they've got a Apple whatever it is with a Siri thing that is plugged in, and all these kinds of things are out there. So it's not just those things. It's the literal traditional IT devices that not everybody has a great handle about what's running on.
So Chris, comment on some of that complexity, and then for both of you, I'm going to come back to. Let's remind folks that anything with an IP address, an Internet Protocol address, it's the social security number of a device, a MAC address, an IP address, whether it's V4 or V6. This is why things are ubiquitously connected and also require constant 24/7 patching. So I took that away, Dave, from it doesn't stop anymore. It's not every 3 years, check out what you have and give us what you have and we'll do. We need constant monitoring of this infrastructure. And frankly, I think the feds and industry and anybody they may not know what they have. Thank God there are tools that can find those things quickly. And that's where I think you all come in and say, all right, we now kind of have a sense of what you have. Let's figure out how to mitigate risk to it. What was some of your thoughts when Dave was talking?
One of the things I said about mobile, and as a sort of throw,
just threw it in there. There's mobile devices too.
It's because generally, from what we've seen, all the agencies run their mobile very tight, right? They've got mobile device management systems. They keep them up to date. It's very well controlled. Same thing with endpoints, right? Where it gets squishy again is with the IoT piece. Endpoints and network devices, everybody's managing those, taking care of those. It gets squishier though, like I said, with the IoT, right? So it's not as you can blanket scan, right, and find things, but if you're not having credentials or if you're not looking at it tighter, you might not be able to see the firmware version of something and know that it's actually this. And that's much more difficult because all of these IoT devices, they're not hooked up into central identity management systems. You can't use a single sort of way to get in. It's much more specific per device. Some are old, and you may not have an interface where you can get in on it. So it's a much trickier, much more difficult task to undertake. It's easy enough to find that there's devices everywhere, right? As long as they're sending out a signal, you can find them, or you can passively find them. But managing them does require special tools, right? And there are vendors and things that have tools that are there to manage firmware on devices, but it's a different kind of thing, and it's an existing threat vector that, in my opinion, doesn't get enough attention.
I love that. And I'm gonna, for our audience, just to define asset discovery according to 23-01 is a building block of operational visibility. And it is defined as an activity through which an organization identifies what network addressable IP assets reside on their networks and identifies the associated IP addresses, hosts, which could be your edge devices, your mobile devices. It's critical, and it's one of the two elements. The second one is the vulnerability enumeration, which is defined as what identifies and reports suspected vulnerabilities on those very assets. And again, I bring this into the discussion. This is yet a year ago when DHS or CISA came out with, here's a guidance and an update on what agencies need to be doing so that we can continuously monitor what's on our network. I know we didn't dive too much into CDM and that program, what it stands for, but you hit on those, Dave, the pillars of the cybersecurity framework. We have a new national strategy, cybersecurity. I encourage everybody, in March of 2023 came out, just read the introduction where it addresses IoT in this world that we moved into. And it doesn't get into, I did a search on it. Firmware was not even a word in the national cybersecurity strategy. But everything you two have spoken about today says that the underlying infrastructure of this world that is becoming IoT and zero trust, going to get into that, it just makes sense that we have to be on top of this. Are you seeing the government do more than just meet the mail? Not that it's their intent, but that knowledge, there's a national cyber education and workforce strategy. Sorry if I messed that up, friends in OMB. But there's a lot of chatter about workforce development. Tools are not taking over. There's plenty to pick from. Again, CGI, I'm sure, can come in and say, these are what you need to do. But there's an educational component. What are you seeing in that federal landscape comprehension of why they should care about the things we've talked about? Dave?
I think as the ability of CISA to issue binding operational directives has, A, it started, and then B, they have done it. I think probably the one that has kind of been the most eye-opening for people is BOD 2301, because it provided some explicitness about things that needed to be looked at, where in the past I think a lot of people did do it, but not necessarily very broadly. There was, but now one of the things that we see is questions around I know I have these kinds of devices. Now what do I do about it, about scanning them for vulnerabilities and having conversations about because now we're going to cover the broad spectrum of the traditional devices that can be have on-device agents that are reporting back to a manager of some kind, credentialed scans where you can actually reach into the device and enumerate its configuration, check what firmware or software or operating system is running, and compare that to other things. Then you've got a whole series of other devices that maybe don't have that ability. You have to, and BOD 2301 provides some coverage points where the agencies in consultation with CISA can come up with strategies to provide as effective of coverage as possible given the constraints of the devices. So it has been very eye-opening. In some cases, it's a numbers game, but the numbers are only one part of it, right? When you look at coverage, you're like, okay, well, the desire is I have 100% coverage of 100% of your assets. Well, to start off with, you got to know what 100% of your assets are in order to do that coverage. But within the bounds of reasonableness, I think 2301 has been probably, in my view, is one of the most effective in raising awareness about the actions that the agencies need to take. Some of these things are going to be, take time to really get to fruition, but it has made a big difference, I think, in what we are seeing in conversations, not only within the agencies that we support, but as we're talking to our peer groups who are supporting the other FCEB agencies, the similar conversations are taking place.
Really quick, just because I was waiting for an acronym that I could define for folks, because you're so good at it. Federal Civilian Executive Branch, FCEB, it was called out in this directive, and I appreciate that. Again, this is a year old, folks, right? We're cybersecurity month. We're fiscal year 24 here. And Chris, I guess to kind of summarize, but again, feel free to riff off some of this. I think this document too, it just represents what's happening in our world. Zero trust, a framework, not a solution you buy, has to be thought about, in my view. I was a former CTO at the Department of Energy and Education, and I would bring in the wonderful folks like yourselves and say, how do I think about this, man? That was why I was getting at. The education of the federal workforce is critical. And I say to all my colleagues in government, you have to learn this stuff too. Sure, you can call CGI, but they're going to teach, train, and believe that you're going to be monitoring a lot of this stuff, these assets that could be putting you and the agency and taxpayers at risk. Net. The document 2301, again, folks, it says right here, the requirements of this directive focus on two core activities essential to improving operational visibility for a successful cybersecurity program, that being asset discovery and vulnerability enumeration. Chris, thoughts on what Dave said?
Well, I agree. Also, just the conversations have gotten better, right? So just not just since 2301, but since decades ago, it's much more. It is much more informed. Absolutely, the education is much more out there. CISA's been doing a great job with putting out BODs, putting out communications. They do a lot of outreach. It's really changed things. They really engage with the FCEB folks, all the civilian agencies throughout, and it's shown the work that's been put in is bearing fruit, I believe.
Let's give an art of the possible, close this out. I'd like to finish with, what'd you take away from today? What do you want the audience to know? It could be something you're just thinking of through the dialogue. There's no perfect answer. This is a continuously must be monitored effort. And I just hope that the audience today isn't thinking that there is a quick fix. We'll go hire somebody. There is an onus on that to be, in simpatico with industry as well as our government folks. So with that, a parting shot. Dave, what do you want to leave with the audience today based on this topic so they can think about something tomorrow that they didn't think about today?
It just goes back to the, zero trust is about removing implicitness. You want to explicitly allow what you want to have happen. So if you have an IoT device that needs to call home in order to check for updates or whatever, then you need to be aware of why that is and put it in a place, network segment, whatever. That kind of thing. You've got to identify, this basic cybersecurity framework is, you can't protect what you don't know you have. And so, Chris, you talked about your home Wi-Fi. You're upgrading 60 devices. Well, you need to enumerate those devices. I was telling you offline, my wife fosters kittens, and she likes to watch her kittens. Right now we have 13, I think, total in the house, and she likes to watch them when she's not physically in the room with them. So I have had to set up some cameras, and I patch them regularly, and they're on their own VLAN and all the rest of that kind of, the typical networky guy kind of thing. But if you go back and, all the cybersecurity professionals out there listening, that your mom or your sister or, your brother or somebody wants to watch their kittens, and they go to Best Buy and buy the Mark 101, $4 webcam. There's a risk there, and
it's not plug and play.
The same thing is true in the federal space. There is a risk to all of these devices that are showing up on your network. You don't accidentally stand up laptops, and you don't accidentally stand up virtual machines. There's processes for that. But, somebody could come in and plug a smart TV into your network, and if you're not doing, port level control or whatever it is, you now have a potential risk. And it would be very useful to know that device is on your network so that you can take action. This is not a punitive thing. This is you need to know what is happening all the time.
A lot of tweetable moments in there. Awesome, and I love the kitten example. It's not as simple as, hey, I got a camera, look what I can do now. Chris, parting shot.
Sure. Firmware. Learn to make it part of regular scans. Develop strategies around how you're going to scan it and check it for vulnerabilities. Some of it will be easier than you think. Some of it will create challenges for you, right? But you can trace it as a gap. Look for ways to do it. In the meantime, with what you do is you can segment these things off, as Dave mentioned. Explicitly allow them to communicate with everything they need to do. But that network segmentation is an important piece of that. But the bigger picture there is to know what is talking to what. Do that network modeling where you know that these devices need to talk to these devices. Do any of these devices need to actually talk to the internet? Does anything from the internet need to talk to these devices? And when you're looking at it from those perspectives, and does this thermostat need to be able to speak to any of the laptops and throughout my entire network? No, it likely does not. So you need to be conscious of these things, right? Do that network modeling, and then set up your network segmentation around that, right? And there's plenty of tools that can help with that, but it can also just be done through straight analysis. Again, I say it all the time, but packets don't lie, and that lets you know where your communications are going and where those communications are coming from. So pay attention, analyze it, and do that. Software-defined networking certainly helps you when you're doing these things these days. Traditionally, all of these sort of zero trust capabilities have been around forever, but they've been impossible or near impossible to actually implement and run effectively. The tools exist now to go ahead and allow for that.
And I would say, in my parting shot, is there is a whole separate discussion we can have on doing that technology due diligence, but I like the fact that comes with the CGI package. I want to thank both of you for your wisdom, for your education. I felt smarter just after this last hour, believe it or not. I actually want to go learn more, and I appreciate your passion. So thank you as we embark on a new fiscal year and address cybersecurity at a much higher level than we did a year ago. And again, just thank you for your time.
Well, thank you. Enjoyed it.
Thank you.
You can find CGI Voices on your preferred podcast platform or watch the video version on YouTube. Subscribe or follow and spread the word to your colleagues. CGI Voices, expert insights for federal decision makers.